Welcome everyone to this webinar, to the first webinar of the webinar series on Kubernetes, enabling and establishing DevOps Sec. Today's topic is going to be about cloud understanding on Kubernetes. My name is Jurlind Budurushi and I am the head of security at Cloudical. I'm currently working on security challenges in the cloud native ecosystem, focusing on Kubernetes. And today with me is my colleague Alexander Trost. He's going to also introduce himself and continue with the first part of this webinar, and I will be involved in the second part. So Alex, the stage is yours.
Hello guys, my name is Alexander Trost. I'm a DevOps engineer at Cloudical, and well, I'm going to take it away for the first part. So when we are looking at Kubernetes, looking at like exactly what it is, like if it's always a kind of mixed thinking on what it is, at least from a definition, kind of definition from the official Kubernetes.io website. It's Kubernetes KDS. It's an open source system for automating deployment, scaling, and management of containerized applications. And if you think about it, maybe you have already worked with Kubernetes, you can kind of agree with that. And that's in itself, that's kind of what Kubernetes is. But if a company, for example, is going to use it, there's so much more behind it. It's not just, well, yeah, we're using Kubernetes, so there's not just the open source system for automating deployment, scaling, and management of containerized applications behind it, but there's also kind of basically cultural change involved as well with Kubernetes there, as is with most software tooling. The point with Kubernetes especially is, well, it's open source. You can take it, you can do whatever you want. But the second kind of part there with the giving, well, how should I put it best way? With open source, it's not just about you, for example, taking Kubernetes and, well, you're using it, but also kind of giving back, where it's, I'm not, with the giving back, it's not necessarily meaning, hey, you're going to give back like, well, multiple people coding on a project as well, like, for example, working on features and such. It's not necessarily that, but it can also be small things like documentation changes. And, well, if you think about the whole open source part of Kubernetes, that's, from our perspective, an important thinking for companies that want to use Kubernetes as well. Because, well, what is a Kubernetes platform good for if the company basically remains with the old thinking and still keeps like the whole idea basically of having everything kind of restricted, if you will so. That's kind of the part where like open source is not just about you open sourcing some code or something, but at least from our thinking, also a way of just in general having it in the company, like having, for example, every documentation available in the company. So it's not just about completely publicizing it to the public, but it's also already starting at you in the company with code projects and such, where it's, for example, getting less restricted. Maybe if you're using Atlassian Confluence as an example, it's primarily used, well, for documentation and such, and that's perfect for it. But the main point, exactly looking at open source there, would be that that you're able to modify any page, that you can edit, well, technically also delete any page and also add new pages as you need. And that's more or less the, that's sometimes missing in companies where the people, well, would like to change things, but they can't, for example, because they only have read-only access to a certain, as I said, like for Atlassian there with the Confluence, and not have enough access permissions to the to another space there. But the whole idea, especially looking at something like Wikipedia and such, is that anybody can change something or even delete or add new pages. And that's an aspect that should normally also come with Kubernetes, that we're understanding as a, well, default thing, that the company is not restricting things too much, at least on a coding and such perspective. That, for example, the application code is freely available. To technically speaking, every developer, for example, that the people can look at each other's code. And well, as said, for open source, it's not just the taking and giving in a public way of you donating money to, well, CNCF or something, or even joining the CNCF or so. It's already starting with you inside the company being able to easily update documentation or something, or even taking it a step further, you as a Java developer seeing some issue or something in code in another project, but while you're searching some other code through the search function of your source code management, and, well, for example, you fix it, and everybody is happy about you fixing that, modifying this code. Well, obviously, hopefully through a review process and all that stuff that should be in place for like continuous integration and all those things. Those are also huge points. But that the people are happy about it. It's not like the people are not seeing it as like, oh yeah, it's, well, it's just kind of like he's kind of shaming us that we have had this issue or something in the code. That should hopefully never be the case for people thinking that. And yeah, that's a part of open source there, where it's not just you open sourcing code to the public. It's already beginning with you having this, well, open mindset internally. Yeah. Going back further to Kubernetes in itself, to the Kubernetes project then. Well, it tries to address certain challenges from you being able to easily deploy an application through one API, let's say. That's one of those things that's, well, it's more or less a feature if you think about it. It's not necessarily an addressed challenge, but having this one API to easily roll out your container image to your platform. That's one of those big points that makes your life as a dev and even ops person in the end easier. And yeah. As a second point, the whole ecosystem that is growing around Kubernetes, it's, well, that's one of those other points which is making the life of dev and ops people easier. Which just like Helm, for example, if you've heard about it, it's a way to easily template certain, well, technically speaking, templating applications, depending on how they're used, even like more generic, like Java application or something like that as well. But in general, you have all those cool tools around Kubernetes, and because of the big and never, hopefully never ending growing ecosystem around Kubernetes. And that's just great. Like having all those tools at your disposal makes your life in the end so much easier, with also new, well, trends in quotes coming up from that, like service mesh and, well, and what do we have? Service mesh right now is, there's probably something with blockchain in as well. And like there's so much stuff growing around Kubernetes, which is so great to see. Well, it's one of the cool points. To come back to the first point with the one API to rule them all, as I just kind of, as with the whole ecosystem part growing into that, if you are working at a company that is using Kubernetes and you're moving to another company which is using Kubernetes, that makes it so much easier in the end to have the same API for you to be able to get started working on the Kubernetes cluster, or well, for example, developing a new application, because you already know what is going on. It's just a Kubernetes API. You just need to apply the same, well, manifest, or well, slightly different depending on the Kubernetes version that they're running. But in the end, it's boiling down to you're able to get a quick start at other companies which are also using Kubernetes, or well, or even OpenShift. It's one API. Well, it's YAML, JSON, or well. I want to see people write JSON like for all the application, unless it's not automated. No, but well, point is you have one format normally, one structure, and that is the way to get your container application, containerized application on the platform with ease. And with a lot of tools, you have automation and all those things with ease for that. And yeah. The third point is also just playing again into the first point with having this one API to rule them all. Because the third point is basically about being the lower time to market, well, if done the right way. Because if you have one API and you have all those projects, software, products, and all those cool things around Kubernetes, focusing especially also on Kubernetes, you can, with ease, get your application, well, CI side integrated, and even CD part deployed, delivered, deployed, whatever you want to call it there, onto the platform with ease. And through that, for example, like have new features, like especially taking COVID-19 currently going on here as an example. If your company has something, well, to do with COVID-19 and is able to, well, in just a few days, roll out new features which can help people, for example, get more new information or something on COVID-19, or like, you know, the company situation, for example, that kind of, well, simply allows you to have a much faster, or well, a lower time to market, allowing you to maybe, well, financially speaking, get some more revenue or something. But, you know, well, in the end, it's about the money, but we have those cool points. Well, and with Kubernetes, especially also there, like you have those those words like agile, DevOps, and well, DevOps and so on, like floating around. A big thing a lot of people are missing there. The Dev and Ops, and even if you combine the DevOps part, it's just one part in the end of this new world, of this new, you have one API, if you have done it right, you have your Kubernetes cluster, or can be even clusters, multiple, and are easily able to to do, for example, your work as a developer or as an operations person, make sure the applications are running. But that's just one, or well, two parts in this case of the new world. There's more to that. And that's where Jurlind will take over there and go into security, why that also is a part of the new world.
So thank you, Alex. As Alex already mentioned, he was started with open source, and why this is very important also from his perspective, being a DevOps engineer. I would like to start with that first and say why this open source is also very important from security perspective, because with open source we would be able to identify bugs, to identify malicious code. So this would also add on top of that what Alex already mentioned, and to improve the security posture of your applications, of your platform, and wherever you are being into the stack. What I'd like to start also with in here is with a definition. So how we see security at Cloudical. And we see security not as a product, as unfortunately this has been misinterpreted or misunderstood a lot of years, but we see security as a continuous and integral part. And it is a multi-layer and a multi-dimensional process chain, which it comprehends technology, it comprehends the people using this technology, the environment where the technology is being used, and of course, the interaction of all of these. when you go to the Kubernetes page, you would see something like this on a very high level view on security, and you start on the bottom with the cloud or something like co-location or the corporate data center. On the other level, you would see the Kubernetes cluster itself, and the next level would tell you the containers, and the other one is the code. So we all agree that this is a very high level view on the security of Kubernetes, and by seeing Kubernetes and by looking into Kubernetes itself, we know that this is a very complex platform and complex tool. And we also know that complexity is the enemy of security. So that's why we want to understand this complexity, and we want to make it as modular as possible in order to improve its security, in order to understand that better, where we can start and where we can improve things, and where actually are the things to be looked from a security perspective. So going to the next kind of perspective, which is the architecture overview on that. Let's see the architecture. So we start at the bottom with the infrastructure. Alex, could you please? Yeah, thank you. With infrastructure and the hardware. The next level is the operating system level, which this can be hypervisor type 1 or 2, or just in host operating system. Alex, you have to help me with that. It's unfortunately not working with, yeah, thank you. So the next level is the runtime management. And as we see also the underlay and the overlay network, which includes starting from the hardware up to the runtime and management. And on the most upper level, we have the application and libraries, but we shouldn't forget I'm sorry for that. Yep, so I'm back. We have some difficulties with this, but no problem. So the upper level is the programming languages and patterns, programming patterns. So this is the architecture overview when we look at Kubernetes, or when we look at this high level overview, and we want to look deep inside this and to understand what is actually being behind that, and to make sense of where we have to look from a security perspective. So while we have identified the architecture, we want to understand the other perspective on the security. It's to have an holistic view on security. So if we only address one security challenge, like for example, let's say access control or user authentication, this doesn't mean that we are secure. If we just install an antivirus, or if we're just doing some logging and monitoring and nobody is looking into the data and what's happening, or we don't have any tools like, let's say, intrusion detection systems, or let's say intrusion prevention systems that are helping us to make sense of this data, and that are helping our operational team to understand and to identify problems and issues that might happen to our infrastructure. So this actually is no good at all. That's why it is important to have an holistic overview on that. And we can start top down or bottom up. This doesn't matter. But for example, let's start from bottom up and from the infrastructure. So let's think what is actually important in the infrastructure. So thinking of the infrastructure, you have to think about physical access into the infrastructure. So who is allowed actually to enter my data center? Are people being authenticated before they're going into the racks and touching the nodes and the computers that we know so far? Does the data center has a disaster recovery strategy? So what happens if an earthquake happens? Do we have a resilience strategy when we talk about the data center? So meaning that it doesn't matter what happens, our system, our critical system needs to be running. They need to be available for all our clients and for our business to be running. Going the next level up, we end up at the hardware. and at the hardware, and we have to think about up-to-date authentic firmware. And this up-to-date, it's gonna follow us and it's gonna accompany us through all the levels. So I will repeat that, and I will not get tired into repeating that. But also in the hardware level, we need to think about updates. So it's our firmware that in the hardware, is it up to date? And on top of that, we have to think on the hardware, what kind of hardware security modules are being provided with the hardware that we are using. Like, for example, trusted platform modules. Is the hardware security configured? Which means, are they, for example, services on the hardware that we are not using, that are not necessary to be used? In that sense, are they being disabled? Or are they, for example, security modules being enabled? Is this, for example, let's say, secure boot enabled? So we are sure that we are booting from a secure operating system, and that nothing has been changed until the last time the system was not working and or was not was not turned on. Going the next level, we are seeing the hypervisor and the host operating system. So the hypervisor does not change much from an operating system. So let's say I put them together because from a concept point of view or from a holistic point of view, the same point needs to be thought and needs to be addressed and are important. And here, as I mentioned before, we have, again, we have to think about updates. So are we using an up-to-date and authentic operating system or hypervisor? Is this, are the drivers that the operating system or the hypervisor is providing, are they authentic and are they up-to-date? Does the operating system or the hypervisor provide, for example, security modules? If we think, for example, in Red Hat distributions, we might think about SA Linux, which provide a specific mechanism for access control, which is so-called SA Linux, talking about mandatory access control. So in that sense, we don't have the default access control on the Linux operation where the owner of a file can do whatever with the file, but we can define security levels, security categories, and we can increase the security of that operating system. On the same level, we also have to think about hardening the operating system, meaning, are we using all the services of the operating system? Do we need all of them? We know that code of operating system, modern operating system have about 100 million lines of code. So we know that the more the code is, the more complex the systems are, the higher is the probability that we will have bugs or we will have some issues on that. So it's best practice, of course, and it is important to know that the services that we don't need from that kind of piece of software, that they are shut down, and so we are reducing the attack surface. Of course, here on the operating system level, we also need to think about logging and monitoring, and of course, on that level, as on the physical level, when we thought about the infrastructure, who is entering my data center, we also need to think here about a transparent access control and role model, so that we know who has access to this operating system, what are the users, and what kind of permissions do these users have. Going the next level up, we are in the container runtime and management. And so there is where we actually have our Kubernetes sitting as a platform. So in that, in that environment, we have to think again and again about updates, about authentic versions. Are we using an authentic version of the software? Are we using authentic container images that we are pulling into this, into that management level? Again, about hardening. Do we need all the services that this complex tool is providing us? If we don't need the services, we better know which the services are that we don't need, and we turn them off. We need to think about secure configuration. So what does secure configuration in this sense mean? I will talk in the next couple of minutes about that a little bit more, but I want to emphasize here that it's important, for example, to think about isolation of resources and secure internal and external communication. We have to think about also secure storage and distribution, for example, of secrets. We have to think again, logging and monitoring, and the transparent access and role control is the same, plays the same role as it plays the level above and the level below, talking about the hypervisor and the container and the applications. On the side, we see the underlay and the overlay networking. So we see that this starts from the hardware, which we have to think about what kind of switches or routers we are using. The same, are these switches and routers, do they have non-vulnerabilities? Are we using an authentic firmware or an authentic software on the routers and on the switches? Talking about the different services that we are using, like VLAN or VXLAN, which enable us to do segmentations in our network and to divide the networks in parts where we can put things that are critical to us, that process critical data, that have to be protected and not accessible by not only external services or external users, like coming, for example, from the internet, but also within our company network, also within our own network. We have to think about network segmentation and put the components into the specific part and into the part which is as appropriate. Going the next level up, we see the containers, which actually, if we put them together, we have the applications and their dependencies or libraries, I would say, and here the same concepts apply. As I said, for example, are we using here up-to-date and authentic version of an application if we are not developing the application ourselves? Are we using, and if we are developing the application ourselves, are our developers using software patterns which enable them not only to be flexible into adding features and into creating a better application, but also into identifying issues that might arise or during the debugging? Do we use security tools when we develop application, like static code analysis or dynamic code analysis? So are we using, for instance, sandboxing in order, before we using a third-party application to understand the behavior of that application and maybe to identify malicious behavior? And also in that sense, we have to think about transparent role and access control also on the application level, if necessary. On the upper level, now we see the users. So the users can come from the internet, they can come from the intranet, and they can also have direct access to our physical environment. So even with that, we have to think about, from the users, on two things that are very, very important from a security perspective. First is authentication. So how we can make sure that the users are uniquely identified and authenticated, and we use strong authentication mechanisms like two-factor authentications, or we are thinking about further educations. Are we educating our users on the dangers and on the risks that are out there? So, and the security posture is changing very dynamically and very rapidly. So we need to keep pace with them, and we need to educate our developers and our users on that. So it's our duty to do that. Again, we do not have to forget the clients that the users are using. So are this client that the users are accessing our environment also compliant? So are this client maybe not a danger or a risk to our environment? So this is so far from an holistic overview, and I would like also to go into the platform itself. Alex, if you might help me please to go to the next slide. So thank you for that. From a platform overview, a security platform overview, we have a very general architecture overview here on Kubernetes. Nevertheless, what is actually here important from a platform overview? So if we look at best practices on that, we have to think about, as I mentioned before, access control. So we have to make sure who has, for example, access to our API server, which is actually like the heart of the Kubernetes. Through it, many things are done. We have to think about encryption at rest. Are the data that we are using, or is our, for example, storage and data that the environment is processing, are they encrypted at rest? So that if someone accesses this data, they cannot make sense out of that. In addition to that, we also have to think about encryption and transit, meaning is the communication within the cluster or even outside the cluster when someone accesses the cluster encrypted and secure? Again, hardening is the same topic. Are there services that we are not using that we don't need? So we need to turn them off, and we need to make sure that nobody can enable the services intentionally or unintentionally. Again, as I said, secure configuration, thinking about, are we using also segmentation concepts also, as we said, on the network layer, even on the Kubernetes layer? So are we using namespaces, for example? So we are not putting everything on the same namespace. So if something goes wrong, then the whole cluster is affected by that. So, and with that, we make it difficult. So for an attacker or someone malicious or a third party trying to mess up intentionally or unintentionally with our cluster, and to not let them to do, for example, lateral movement, starting from our cluster and maybe moving towards or forwards to other parts of our environment that are more critical to us. Are we using logging and monitoring? Do we think about separation of duty, so that not all the users have the same rights? So we have to think how we actually are making sure that we do separation of duty, how the users are divided in different roles, and they have different permissions, and they can do different tasks. And last but not least, also availability is your issue, thinking about, for example, garbage collector. So garbage collector is, for example, one feature that you can enable in Kubernetes that helps you, for example, not to make your cluster, so gathering a lot of garbage. So with that, I would like then to thank you for your attention, and me and Alex would be very happy to take and to answer your questions.
Yeah, should you have questions, there should be a forum in Zoom available for you, or a button which should allow you to submit a question if you have any. Yeah, should you not have any, well, thanks for listening, as Jurlind already said, and we'll hope to see you in the next in the next part of the series. Yeah, have a good day.
I'd like also to mention that you can always reach us via email. So if you have any questions on that, or if you have any interesting, so one question pops up, I think, what topics will be next? For instance, if I may, Alex, from the security perspective, we saw 3 different perspectives. One was the high-level perspective, the other one was the holistic perspective, and we also saw the platform perspective. So the next topic will be the life cycle perspective, the life cycle management when we use Kubernetes, like the deployment pipeline. So this would be, from the security perspective, the next topic. I hope this answers your question.
We have not received any more questions. So then, as said, thanks for attending, and we hope to see you in the next part of this series.
Okay, bye-bye.
Have a good day.